Look, everybody knows at this point that having a portfolio of projects is going to help you get a job in data science. But I promise you, if that portfolio is just Kaggle projects working on the Titanic data, doing some boring exploratory analysis or data visualization, you're probably not going to be getting called back for very many interviews. Hiring managers want to see unique projects. They want to see that you're passionate enough about something to maybe even gather the data yourself and to do something cool or unique with it. Which is why I, an avid old school Runescape player, am going to show you how I would use Python to make a portfolio project that really stands out. But even though it might seem like the subject of this portfolio project is kind of silly, I promise you it would be a lot more appealing to a hiring manager than one of the millions of people that's done a classification on the iris dataset. So we're going to be breaking this project into 3 parts. The first part, we're going to be using web scraping to gather some data about a boss in old school RuneScape. The second part, we're going to be cleaning that data and creating a function to help us predict something. And the third part, we're going to be putting that into a simple web interface that would allow users to input some data and get a unique output. Now, like I said, I am an avid old school RuneScape player and nerd, obviously, but my career has been taking up quite a bit of time recently, so I've not been able to grind out boss kills like I'd like to. So for this project, what I'm going to do is build a predictor which will allow me to just simulate boss kills, so I could kind of get that little dopamine rush of getting a particular drop without having to spend thousands of hours. And we're going to be doing this on a boss called Zulrah. So without further ado, let's jump into part 1, which is going to be the web scraping. But before we do that, I'm going to turn off this LED behind me because it'll probably blind me otherwise. Much better. Now let's jump into it for real. So like I said, the first part's going to be about web scraping, which means we're going to start by looking at the old school RuneScape wiki page for Zulrah, and we're going to try to get the drops from this page using Python. So let's have a look here. First, let's scroll down to where the drops are. Now, we'll spend a little bit more time in the second video working on the actual mechanics and recreating them. But for this video, all that we need to do is get the data from this page into Python so that then we can do the rest of the project. So when we get down here to the drops part, you'll notice there's a few different tables which contain information about what items the boss can drop. What we want to do is grab the information from just these tables and put them all into one big data frame where we'll do a lot of our work on calculating probabilities and things like that. But you'll notice there's some tables down here below it as well. And there's definitely some tables up here at the top as well, like this is a table. And so what we'll need to do is find a way to just get the tables that we want. Now, you could just get every table and sort of chop the tables that you don't want off, just using the index. But I don't really want to do that. I want to make sure that this project looks good as a portfolio project. If I was just hacking together a solution, I might just grab every table and manually take out the ones I don't want. But we're trying to make this look kind of professional and show off our skills. So anyway, let's get started. We'll go ahead and copy the URL for this page. Let's make sure we're just getting the whole page. Yep. So we'll go ahead and start by copying the URL, and then we'll go to our Jupyter notebook. I like to set up my notebooks like this with a little information about what's going to go where. So we'll start here on part 1. So the first thing that we're going to need to do is import a few packages. But first, just so we don't lose it, I want to store the URL for our Wikipedia page there. Now, I've already got some code written that I'm going to use sort of as a guide just to help speed this along, but I'm going to be explaining how everything works, and I'm going to be showing you how I got to what I got to. So just so you know, if I ever copy and paste something, it's because I've done a little bit of research ahead of time. So these are all the packages that we're going to need for part 1 and 2. We won't end up using all these today, but we'll get to that when we get to it. So first thing, store the URL in a variable. I always like to comment my code as I'm going. It's a lot easier than trying to go back later on and add comments when you don't really remember what you did. So I'll always comment through my code as I'm writing it. So the next thing that we're going to do is access the contents of the web page. And we do that using the request packages. So requests.get, and essentially this takes 2 arguments. The first argument is the URL, and the second argument is what's called the headers. Essentially, Headers are information that you feed the website that sort of explain a little bit about who's accessing the web page. Now here you might notice it says user agent Mozilla 5.0. Essentially what this is going to tell the web page is that we are a regular person accessing the web page using Mozilla Firefox. And this part of web scraping can be a little bit controversial because sites often have terms of service that they try to get people to follow about web scraping, because if you're pinging the site too often to scrape data, then that can be very challenging for the site to handle, and a lot of times you'll get an error and you won't be able to continue to ping the site because you've done it too much, and they don't want to have to use up all their bandwidth on someone who's just web scraping rather than someone who's trying to use the site. So in this case, we're saying that we're a user agent using Mozilla. If we were going to be pinging the site over and over again, I'd look at the site's terms of service and see how many times per hour they want you to be able to ping the site. But since we're just going to do it once at the beginning, and then we're going to be using the data throughout the rest of the script, doing something like this is okay. But whenever you're going to be web scraping, try to be considerate of the terms of service of the site. Okay, so that's going to give us a response from the web page. But then what we need to do is get the HTML out of that response, because it's going to have a number of things, not just the HTML. So extract HTML from response. So to do that, all we do is we say page content equals response.content. So now we've got the raw HTML. We're going to use Beautiful Soup to parse that HTML so that we can actually access different parts of it. So to do that, we're going to say soup equals Beautiful Soup, which is just a package. And we're going to feed this the page content. And we're going to parse it using LXML, which is just a parser for HTML content. And yeah, so that's our start for now. So right now what we've got is a readable version of the HTML. And from here, what we're going to want to do is we're going to want to grab the tables from that page, because the loot data, like we discussed at the beginning, is stored in various tables. So the first thing that we're going to do is find all tables in the HTML. And so what we do that is we're going to store it in a variable called myTables, and we're going to say soup.findAll, just a function from the Beautiful Soup package. And we're going to say table. And like I said before, I want to be able to just get the loot tables, but in order to do that, I need a little bit more information from the web page. Because you can do this, and this would return all of the tables on the entire page. Or you can feed the findAll function a second argument called attributes, ATTRS, short for attributes. And we can look for tables only of a certain class. And each table is going to have a class, which sort of tells the web page what type of table it is. And to get the class of the table, we can simply go back to the web page and inspect it. So let's do that. So now we're back here in Chrome. We're going to hit F12 to inspect. And let's scroll back down to where our loot tables are, right here. Okay, so we're going to click this little guy right here, and we're going to hover over the table itself. Sometimes it can be a little challenging to get right where you want to be. Oh, there we go. And over here we can see table class equals wiki table sortable filterable item drops auto sort equals 4 j query dash table sort blah blah blah. So some of what is in that class is dynamically generated using JavaScript, and some of it is actually a permanent feature of the class of this table. So what I'm going to start off with is just using wiki table. Okay, so we're just going to say class equals wiki table for now, and then we're going to look at what tables that gives us, and we'll filter it down more from there. So we're back in our notebook now, and we're just going to say class equals wiki table. And then what we're going to do is we're just going to print my tables and have a look at what that looks like, and then we'll kind of try to filter it down more from there. So let's run it, give it a sec to run. Oh, I accidentally said LMXL, it's LXML. Sometimes that happens, just a little typo can destroy your code, so let's try it again. There we go. And all right, let's see. So the first one here looks like an item drop table. And you see this says wiki table sortable filterable item drops auto sort equals 4 comma A, and that's all it says. if we go back to our table here, you see wiki table, sortable, filter out, and blah, blah, blah. But then after A, there's a bunch of other stuff. Now that comes from the JavaScript. When we're just scraping it, a lot of the JavaScript stuff gets omitted. So it looks to me like this table is class wiki table, sortable, filterable, item, blah, 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 blah. So we'll take that and we'll put it right there. Now let's scroll down a little bit to see if it got any other kinds of tables. Scroll all the way down. Yeah, see, these are all loot. I can tell because these are like loot items. Clue scroll is an item in RuneScape. But you've also, excuse me, you've also got like table header here, quantity, item, things like that. So I can tell that I'm still in the loot. And if you look up here, you've got the table class equals the wiki sortable item drops. But if we scroll down here, you've got another class, wiki table sortable light table. And the header here, you've got description, difficulty, category, Zulrah adept. Yeah, these aren't drops. These are combat achievements. So if we go back to the page, we're looking at this table right here. So I believe that we got the right class for the item tables only with this one, wiki table, sortable, filterable, item drops, auto sort equals 4, comma A. So let's try to run this again and see if it returns just those tables. Items, 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 looks like items, items, and yep, that's it. So that was it. That is the official class of the table that is just the drops. So now we have officially successfully gotten just the drop tables. So that's a good start. But as you can see here, it's still in this table. It's still in HTML. So we've got a little bit more parsing to do with Beautiful Soup, but that's not going to be too difficult. I think we'll find that pretty easy. So we've got multiple tables here. Essentially what we've got is a list of tables. So what we need to do is iterate through those tables and parse them individually. So we're going to say for table in my tables, and we're going to start by getting every row from the table. So we're going to parse out table rows. So we're going to say table rows equals table.find all. Remember we used that earlier. And we're going to be just looking for things tagged TR, which stands for table rows. But we're also going to need the table header, which is a different thing, and it's tagged differently. So we're going to also parse the table header. And the table header is going to have the column titles, which we need in order to make pandas data frames out of this. So we're just going to sort by TH, stands for table header. All right, so once we've got that, let's parse through the header row first. That way we can get all of our column names. So let's say parse columns from table header. So let's initialize an empty list here. And we'll call it columns or calls. And then what we'll do is we'll say for item in header. And each item in here has several attributes. What we want is the text of the items. So we're going to say item text, and we're going to append that to columns. So calls.append item.text. But one thing that you find often when you're web scraping is empty items in headers or in rows, often for spacing, for different like display reasons on the page. So we're going to add a little logical check before we're appending here. So what we're going to say is if item.text, if the length of the text is greater than 0, then we'll add it to the list. Otherwise we won't, because if it's blank, it doesn't have any information, and generally speaking, it's just there for like formatting purposes. Okay, so now we're going to parse through the data of the rows. So we're going to go ahead and create another empty list here called data. And then we are going to say for row in table rows. So we're going to iterate through them again. And we're basically going to do something pretty similar to what we did with the header, but we have one more thing of parsing to do because each item in a table row that is a piece of data is tagged TD. So we're going to have to iterate through those as well. So what we'll do is we'll say table data equals row dot find all td. Okay, table data. So now that we've got a list of all the table data, we're going to parse through it, but we're also going to do a little bit of logical check after that as well, but we'll start with the parsing first. So what we'll do here, and we'll use list comprehension, is we'll say row data equals item.text for item in table data. And what that's going to do is just give us the text of each item so that then we can parse through it and do our logical check as well. So now that we've got the row data, what we're going to do is we're going to make sure that there's anything in it. So we're going to say if length of row data is greater than 0, we're going to go ahead and append that to our data. Because sometimes there's blank rows even. When you're parsing HTML, there's a lot of blanks and things that, to me, a data analyst, that don't make a lot of sense. I'm sure if you asked a front-end or a back-end developer, they'd be able to explain them to you, but for our purposes, all you need to know is that sometimes there's blanks. Okay, so we should have our data after that. And then what we're going to do is we're going to try to put it into a pandas data frame. So I like to call that output frame equals pd.data frame. And we're going to use data, and we're going to make the columns the header row. Okay. And so that's it. So this is going to go through every single table and output it in a data frame format. Of course, it's just going to be putting them all in this variable. So we'll have to do a little bit more to get all the data and combine it. But let's just see what happens here if we run this. So name header is not defined. So for item in header, oh, I should call that table header. Try it again. Header row is not defined. Where is that? Line 49, output frame, header row. Oh, I called it calls. Yes. There we go. Now we've got another one. 5 columns passed. Data had 6 columns. So oftentimes when you're web scraping, you're going to run into a lot of issues like this. So what can be helpful is just to print out the data and the headers. So let's have a look. Print data. Print columns. And we'll just comment that out for now. So let's see. So for this first one here, you see we've got a blank here, and then we've got 1, 2, 3, 4, 5. So we've got 6 total columns here. And these are the columns. Or I'm sorry, this is the data. The column headers, we've got 1, 2, 3, 4, 5. So the issue is that the first piece of data is just blank. So essentially, what's happening here is the first item in this row is blank. So what we need to do is get rid of that useless piece of data. So how can we do that? We can add that to the list comprehension here. Item text for item in table data if item.text is not equal to just a blank, an empty string. So let's try it again and see if that fixes it. So yeah, so we've got 1, 2, 3, 4, 5 pieces of data, 1, 2, 3, 4, 5 column headers. So let's try that, see if that fixes our issue, and if not, we'll keep troubleshooting. And it looks like it did. Let's see if one of these things worked. It did. That's great. That is our last table. Brimstone key, clue scroll, jar of swamp, pet snakeling. That's this table right here. And you see it's got all the data. So we did it. We were able to parse all of these tables. But the problem is right now we're only getting one of them at a time. So we've got to find a way to keep each of them and combine them all into one table. I like to make use of dictionaries a lot in cases like this, where I'm iterating through several things. So let's initialize empty dictionary here, and we'll call it loot tables, and we'll make it empty. And we're also going to have a key, so we'll need to be able to iterate through. So we'll just make a random table index, which will help us do that. And let me just go back here and add a little bit of comments to keep things nice and clean. And there we go. So essentially what we're going to do here is we're going to create a dictionary where each value in the dictionary is a pandas data frame, and each key is just an arbitrary index based on the table's appearance in our list. So essentially what we'll do here, we've got this little indexer. It's going to start at 0. And each time we run through, we want it to increase by 1. And we want to put the data frame into this dictionary. So we'll say loot tables.set default, and the key is going to be the table index, and the value is going to be the output frame. So once we do that, we will have a dictionary with all the tables rather than just having one of the tables. So let's see how that works. Oh, sorry, table index. Try it again. That should work. Output frame. So that's still the last table, but let's take a look at the dictionary. And there we go. So now we've got one entry for every single one. So like if you were to say loot tables 1, then that's the second one because it's 0-based indexing. So if you were to say loot table 0, that was the first one. It looks like we have all of them now. So essentially what we need to do now is just put these all into one data frame. And essentially you can do that just using the concat function from pandas. So we'll say loot table equals pd.concat, and then we will say loot tables, I believe that's what I called it, yeah, dot values. So essentially what this is going to do is it's going to take the data frames out of the dictionary and just concatenate them all together because they've all got the same column names. And then we can just take a look at the loot table itself and make sure it worked. And yep, it does appear to have worked, but the index here is a little strange. So I'd like to fix that by just resetting the index so that it's indexing based on the item name. And in order to do that, all we've got to do is say loot table.set index item, and then in place equals true. And then we can look at it again. And now you can see we've got the item here. So there you have it. That is how you web scrape something that you're interested in and put it into a pandas table for your project. You could use this for any number of things. I've used it to scrape baseball statistics before. So the trick is to find something that you're interested in. It doesn't have to be a video game boss. It doesn't have to be sports. It doesn't have to be anything like that. You could scrape weather data. But the point is to find something that you're really interested in that will set you apart. And so in part 2, we're going to do something interesting with this data, which is we're going to simulate the loot from a certain number of boss kills. And interestingly, there's a few different things we can change about that scenario to change how the loot would actually function in the game. So thanks for watching, and if you felt like the Python here was a little over your head, I've got a great video on how I learned to code in Python in just 30 days right here.